Hi viewers, let us see the working principle of PN Junction Diode. ஸோ எல்லாருக்கும் தெரியும்னு நினைக்கிறேன். இது செவிவழி கல்வி உங்களுடைய சேனல். ஸோ இதில் பேசிக் எலக்ட்ரானிக்ஸை பற்றி நாம் இப்போ பார்க்க போகிறோம். ஸோ இதில் ஒர்க்கிங் பிரின்சிபல் ஆஃப் பிஎன் ஜங்ஷன் டயோடு அப்படிங்கிறது இன்னைக்கு நம்ம பார்க்க போகிற கான்செப்ட். ஸோ அது எப்படி ஒர்க் ஆக போகுது அப்படிங்கிறத பார்க்கலாம். ஸோ பிஃபோர் கோயிங் டு சி இன் டெப்த் ஆஃப் ஒர்க்கிங் பிரின்சிபல் வி ஹாவ் டு நோ அபவுட் வாட் இஸ் பிஎன் ஜங்ஷன் டயோடு. So PN junction diode is nothing but it is a two-terminal device. So otherwise it is called as a two-electrode semiconductor device. So which allows the electric current in only one direction. Because it consists of two terminals, positive and negative. Otherwise it is called as a anode and cathode, which allows the electric current in only one direction, while blocks the electric current in opposite or reverse direction. So current flow direction. So whenever you consider the PN junction diode is in the forward bias condition, which allows the electric current flow. So at the same time, if it is considered as a reverse biased condition, it will block the flow of current. So this is current flow direction in PN junction diode. So next we have to consider how the junction will be made in the PN junction diode. So normally it consists of two materials. One is called as a P material and another is called as a N material. P material which consists of more number of holes, that is majority carriers are holes in P material. Similarly in N material, electrons are the majority carriers. So both two materials are joined together and which make one junction which is called as a PN junction. So this PN junction semiconductor diode, otherwise called as a PN junction semiconductor device. So N type and P type material. So if you consider N type material, so majority carriers are free electrons. If you consider P type material, majority carriers are holes. So how the depletion layer is produced in PN junction diode. So whenever you consider P material, so it consists of more number of holes, and in N region or N material, electrons are present in this region. And when you consider the junction is formed or made because of the joining of the P material and N material. At the same time, if you consider forward and reverse bias condition for PN junction diode, the depletion layer size will be increased or decreased. We will see it in forthcoming PPT. So why we choose the silicon semiconductor instead of germanium? So normally when you consider PN junction diode, the silicon semiconductor has a high temperature. If you consider the PN junction diode, if it is in the form of germanium semiconductor, it has a low temperature. So because of this concept, instead of germanium semiconductor, we prefer this silicon semiconductor. So these are the symbol of PN junction diode. So basic symbol, both are considered in forward bias and reverse bias. If you consider PN junction diode, it has a two category of biasing method. One is called as a forward biasing, another is called as a reverse biasing. So in forward biasing, anode terminal is considered as a positive and cathode terminal is considered as a negative. Normally the current flow direction is from positive to negative, that is anode to cathode, that is conventional current flow direction, and the electrons flow from cathode to anode, that is the electron flow direction. So this is for forward biasing. Similarly, if it is considered as a reverse, anode means the power supply or battery is connected with this negative terminal and the cathode is connected with the positive terminal of the battery. So which is connected in this reverse biased. So before going to see in depth of this concept, always you have to remember the conventional flow current must be from anode to cathode, and the flow of electron direction must be negative to positive. So this is the block diagram for forward biasing of PN junction diode. So here the P region consists of more number of holes, which is called as a anode. And here the N region consists of more number of electrons, and the end of this element terminal is cathode. Now we can consider the battery. So the battery positive is connected with this anode of the P region, and battery negative terminal is connected with this cathode terminal. This connection is called as a forward biasing block diagram. So here, when you switch on the power supply, that means if you give the power to this PN junction diode, that means you are giving the battery. So depends upon the applying voltage. What are the different number of holes present in this N region? That holes are repelled with this battery plus terminal. At the same time, the electrons present in this N region is repelled with this negative terminal of the battery. So both conditions are repeatedly going on. So the positive terminal of this battery is repelled with the holes in this P region or P material. Electrons from N region is repelled from this negative terminal. So this is continuously taken place. So the whenever the holes present in this P region are moving towards the junction, at the same time, the electrons present in this N region are moving towards the junction. So the continuously the holes can be moved towards the N region, and the electrons can be move towards the P region, and the electron hole pair will be formed. So at the time the depletion region will be reduced because of rippling of holes and battery of plus terminal, and N region electrons and negative of battery terminal. So because of this rippled condition, different number of holes and electrons moved from one material to another material. That means it crosses the junction, and the depletion layer range is reduced. At the same time, the barrier potential voltage also reduced. So this is working principle of this forward bias condition in PN junction diode. Similarly, if you consider reverse biasing, so at the same time, uh, the reverse process has taken place instead of forward biasing. So the battery negative terminal is connected with this anode of this P region, and the battery positive terminal is connected with this N region cathode terminal. So at the same time, the P material holes are attracted by the battery negative terminal, and electrons from N regions are attracted by the battery positive terminal. So because of this condition, the depletion layer of PN junction diode will be increased compared with forward bias condition. So at the same time, the barrier potential voltage will be increased. So this is a concept of reverse biasing condition. So this is VA characteristics of PN junction diode. So normally we take in x-axis we are considering this voltage, and y-axis consider the current. So here in right hand side, forward voltage, which is denoted by BF, and forward current is denoted as IF. So the forward voltage is yeah, unit is voltage, and forward current unit is milliamps. Similarly, for reverse current unit is microamps, and reverse voltage unit is voltage. So here in forward bias we are applying more current, and the resistance value should be very low. At the same time, in reverse bias condition, current value is very minimum, and resistor value is high. So because of this condition, for forward bias condition, the forward resistance value will be very low compared with reverse resistance. So normally the forward resistance can be calculated with the formula of VR, that is RV, forward resistance RF, which is equal to del VF divided by del IF. Similarly, reverse resistance RR, which is equal to del VR divided by del IR. With the help of this formula, we can able to find this forward resistance and reverse resistance value. So this is VA characteristics of PN junction diode. So let us see the explanation about virtual lab. So the same theoretical concept can be explained in the virtual lab to understanding the practical knowledge. Now we can see the virtual lab concept for forward bias condition of PN junction diode and reverse bias condition of PN junction diode. So let us consider we are going to select this diode IN4007. After that, we can set the resistance value. So, for example, here I choose 1032. So, approximately 1 kilo ohm, and our DC voltage is zero point 0.3 voltage. And here I can add this value into this experimental table and add it to table. Initially, every values are 0 for both forward voltage and reverse forward current, and you can plot it. So we can observe it in VI characteristics graph, and you can increase this voltage value. So again add this value into table, plot it. So again you can add a table. So your value is now 0.532. So you can get the plot for VI and voltage and current relation. Again, you can increase this DC voltage and add it to the table. So when the voltage is increased, current also increased, and you can able to relate the voltage and current. That is VI plot is available here. Again, you can increase the voltage, and we can see this relation between voltage and current is both are in increased manner, and we can show the plot. Again, we can increase the DC voltage, add it to the table and plot. So continuously this will be happen. You can increase the DC voltage and add it to table. Finally, if you plot it, you will get the curve. So this is the silicon diode. So for forward bias silicon diode, we know very well the conduction of this silicon diode is zero point 0.7. So in this forward bias condition, up to this zero point 0.7, we can able to get the answer. So after 0.6 or zero point 0.7, we can able to get the conducting of this diode. So this is for forward bias relation. Similarly, we move to reverse bias for silicon diode. So here also we can choose this IN4007, and initially we can able to set the resistance value. So here I can give approximately 1000 kilo ohm, and I can set this resistance value, so zero point 0.2, and add it to the table, and we will get the reverse voltage and reverse current, and we can able to plot it, and we can increase the DC voltage, add it to the table, and again we can get the relation. So again increase DC voltage, add to the table, we can able to plot it. So continuously we can able to increase the DC voltage. So according to the reverse voltage, the reverse current will be constant in reverse bias condition of PN junction diode. So whenever you increase this DC voltage and add it to the table, the voltage value will be increased in voltmeter and the current will be maintained constant. So this is the relation between voltage and current in reverse bias condition. So in forward bias condition depends on the applying input voltage. The voltage increase, current also increased at the particular 0.6 or 0.7. The cutting voltage occurred. The conduction of the PN junction diode will happen. At the same time, in reverse bias condition of the PN junction diode, whenever the voltage is increased, current going to maintain constant for more number of voltage increasing level. So this is a concept for forward bias and reverse bias condition. Characteristics of this VA plot, both forward bias and reverse bias, we can observe everything in virtual lab in simulation mode. So I hope everyone understand this concept clearly. So kindly subscribe my channel, and if you want to give any comment for this video, give your comments. Thank you all.